Today's webinar is about robotic exoskeletons. So what we'll be covering is what are robotic exoskeletons, how they can help people with movement disorders and impairments, and different types of robotic skeletons. So what are robotic exoskeletons? An exoskeleton is a wearable device or a suit that works alongside the user to enhance their strength and amplify their performance. It is usually worn on the body. Exoskeletons use a combination of robotics and biomechatronics to enable body independence and are designed to help support rather than replace functionality. So this is what robotic exoskeletons look like. So in physical rehabilitation, they help patients relearn skills. In construction, they reduce the amount of energy expended and make repetitive tasks easier. In the military, they are used to help soldiers carry heavier loads over long distances. So how they work is that an exoskeleton contains a frame that goes around a body's user or part of the user's body, as shown in the picture. The frame is sometimes made out of hard materials such as metal and sometimes out of softer material such as a special kinds of fabric. Some exoskeletons contain sensors which monitor and respond to the user's actions and movements. It takes the weight of the user's arms off their neck and backs and shoulders and transfers it into their cords. The energy that workers expend becomes more evenly distributed, which reduces strain and stress on the muscles and joints. There are different types and classifications of exoskeletons, which depend on the body part which they are worn and how they are powered. So exoskeleton classification, the full body exoskeletons is a exosuit that is used for strength augmentation in the military and rehabilitation. Upper extremity exoskeleton is one that supports the arms and potentially the torso. It can further be broken down into shoulder joints, elbow joints, the wrist, and even fingers. Lower extremity, this is an exoskeleton that is used to support the legs. It comes in different configurations like hip, knee, or ankle only, or they could be joined together like hip, knee, knee, ankle, or hip, knee, ankle. So powered exoskeletons, these are exoskeletons that rely on batteries and electric cable connections to work. Powered exoskeletons are divided into static and dynamic exoskeletons. Static exoskeletons, these exoskeletons require that the actuator be on it at all times in order for the device to run well. And dynamic exoskeletons do not need an actuator to be on, which makes them more energy efficient. So passive exoskeletons. Those exoskeletons do not require electrical power in order to run. They rely on other mechanisms in order to work and are good for weight redistribution. The springs in an exoskeleton plus the locking action redirect an object's weight into the ground. And energy capture. Angle spring clutch exoskeletons may help improve walking efficiency. So damping. Some exoskeletons are used as shock absorbers and vibration reducers. And locking. Some exoskeletons can be locked into place, which helps users to stay in one position for a long time. These are exoskeletons that all have as the pseudo-passive exoskeletons. These are exoskeletons that all have features of a powered exoskeleton but do not provide actuation. An example of that is the C-brace by Autoblock, which is shown over here in the picture. So hybrid exoskeletons. These exoskeletons typically have all the features of a powered exoskeleton, but use the input of the muscles as actuators. Some examples: there are a variety of there is a vast diversity of robotic exoskeletons that are available. There are different types designed to serve different purposes. You have to find what fits your need. So one of the examples, one of the types is rehabilitation exoskeletons. One of the most popular use of exoskeletons is rehabilitation. Because of this, there are lots of great options to choose from. So the hybrid assistive limbs, the HAL, Cyberdyne hybrid assistive limb, is used by patients who suffer from spinal cord injuries, cerebrovascular diseases, traumatic brain injuries, and other neuromuscular diseases or injuries. Brain signals to the muscle are captured on sensors placed on the legs, then feed the information to the HAL, which helps the user move and walk around with their legs by merely thinking of moving their legs, according to a video by Brooks Rehabilitation. So the HAL Lumbar Type. The HAL can multitask, serving as both physical therapy exoskeleton and also one to aid healthcare workers, according to Cyberdyne's product page site. The battery-operated HAL Lumbar Type for labor support exoskeleton is designed to provide lumbar support when users are lifting and moving items or people, such as nurses moving patients or seniors seeking physical therapy. The ExoNR, Exos Bionics FDA-approved ExoNR, is an exoskeleton for neurological rehab patients that is used in healthcare rehabilitation centers. The suit is designed to help brain injury, multiple sclerosis, spinal cord injury patients, as well as stroke victims, regain their natural walking gait by reteaching the brain and muscles how to walk, according to Exobionics. The HMEX, automotive giant Hyundai, the automaker developed one to assist patients suffering from spinal cord injuries with the HMEX. This device aims to help patients sit, stand, walk, navigate stairs, and even run if needed. The Phoenix Medical Exoskeleton, Autoblock's lightweight exoskeleton, is designed to help people have mobility disorders stand upright and gain mobility. Phoenix has two devices at the hip that prompt the machine to operate. Its knee joints provide support when users are standing and help them clear the ground as their leg swings forward. The ReWalk Personal 6.0 exoskeleton. ReWalk Robotic Exoskeletons is designed for home use and when users are out and about in the community. It is a lightweight exoskeleton with motors at the hip and knee joints and propels a user forward as they learn into their next step, mimicking the natural movement of their steps. ReWalk stated on their website. The Wandercraft Atalante X. Patients suffering from paralysis may be able to walk again with the aid of this self-balancing, hands-free exoskeleton. Wandercraft states on their website, Atalante X allows patients to stand and sit on their own and walk with assistance. It's designed to be used in rehabilitation tool following an accident or brain injury that causes paralysis. So workforce exoskeletons. Exoskeletons can be also used in the workforce as an aid in injury prevention. The Comau mate exoskeleton mate is used to help production workers reduce upper body fatigue by supporting their shoulder movements and has 8 different levels of assistance that workers can quickly adjust. The lightweight device operates without a battery or motor, and its manufacturer says it can increase overhead task accuracy by 27% and execution speed by 10%. The Exobionics Exovest. Manufacturers and construction workers can get their strength boost by wearing an Exovest, which provides upper body strength and can reduce the stress fatigue on their arms, neck, and other body joints. So other exoskeletons. The option for for robotic exoskeletons are endless. They are used to many other things as well as such as sports and marketing. The Exosapien technologies. So the Prosthesis stands more than 14 feet tall and is solely controlled by a human operator. Electrohydraulics and direct touch feedback, according to the Prosthesis creator Jonathan Tippett on YouTube. Based on a user's hand, arm, leg, and feet movements, Prosthesis can run upward at 200 miles per hour, powered by a lithium-ion battery. Tippett said he developed the Prosthesis to launch a new sport of mechanical racing. The Lockheed Martin Onyx exoskeleton. Military and first responders are the target market for the Onyx exoskeleton. The Onyx exoskeleton, which uses AI, gathers movement data from users' feet, knee, and hip sensors and forwards it to control module stationed on the waist, which instructs the exoskeleton to move accordingly, Lockheed Martin said on its site. The Autobot Pixel-thumb. The world's smallest exoskeleton protects the tip of a thumb and relieves strain on the joints in the hand. The Pixel-thumb is designed to cut 70% of the strain on the thumb joint by restricting the pressure across your entire hand, Autobot said in its report of the small exoskeleton. So some pros and cons. The pros of it is that it allows complex movement due to jointed appendages, provides protection against physical damage and abrasion, increases leverage, and helps heal injury and trauma. Some of its cons do include that it is very expensive, it has a limited power range and limited motion range. So thank you for listening. If you'd like to learn this lesson with a Cyber Seniors mentor, please go to www.cyberseniors.org or call us at 1-844-217-3057 to register for our one-on-one phone session. We also host weekly tech drop-in sessions from 2 to 3 p.m. ET on Thursdays.